Imagine driving down an endless highway stretching for millions of miles, connecting entire cities across a vast, unseen landscape. Now, replace the road with a filament of hydrogen gas and the cities with entire galaxies. Sounds like something out of science fiction, right? Well, scientists have just confirmed the existence of such a structure in space, a 3 million light-year-long filament that serves as a bridge between two galaxies, dating back to when the universe was just 2 billion years old. This discovery not only changes how we understand cosmic structures, but also sheds light on how galaxies grow and evolve. So what does this mean for our understanding of the universe? Let's dive into it. For decades, astronomers have theorized that galaxies are not scattered randomly throughout space. Instead, they are arranged in a vast, interconnected network known as the cosmic web. This web is made up of filaments of gas and dark matter, stretching across the universe like a massive spider web, linking galaxies together. The filaments act as cosmic highways, guiding the flow of matter and energy, fueling the growth of galaxies over billions of years. Until now, most of this cosmic web had been invisible to telescopes, existing only in simulations and mathematical models. Scientists could infer its presence by the way distant light was absorbed by unseen gas, but no one had actually seen one of these filaments stretching across space, until now. A team of astronomers has successfully captured an image of a 3 million light-year-long cosmic filament connecting two galaxies from the early universe. This was achieved using the Multi-Unit Spectroscopic Explorer, or MUSE, instrument on the Very Large Telescope in Chile. The filament is composed mainly of hydrogen gas, the essential building block of stars and galaxies. This is the first time a filament of this scale has been directly observed in such detail, providing definitive proof that these cosmic bridges exist. The discovery confirms what theoretical models have predicted for years. Galaxies do not evolve in isolation. Instead, they pull in gas from these massive intergalactic structures, which fuels the birth of new stars and supermassive black holes. Observing a faint, thin filament of gas stretching across millions of light-years is no easy task. Traditional telescopes are not sensitive enough to detect such dim structures. However, MUSE is a special type of instrument that can capture both images and spectra of light simultaneously. This allows scientists to detect even the faintest glow of hydrogen gas illuminated by the ultraviolet radiation of nearby galaxies. The research team spent hundreds of hours collecting light from a small region of the sky, analyzing the data to reveal the presence of this filament. By mapping the distribution of hydrogen gas, they were able to reconstruct the shape and structure of this cosmic bridge for the first time. Before this, scientists speculated that galaxies pulled in gas from their surroundings, but this was mostly based on indirect evidence. This new discovery directly proves that galaxies are connected by filaments that supply them with fresh gas. Without these filaments, galaxies would run out of fuel and stop forming new stars. Our current understanding of the universe is based on the lambda cold dark matter (LCDM) model, which predicts that dark matter forms the backbone of the cosmic web. This discovery provides strong evidence that the cosmic web exists as predicted, and that galaxies grow along these filaments. Dark matter makes up most of the mass in the universe, but it doesn't emit or reflect light, making it incredibly difficult to study. By tracing the filaments of hydrogen gas, astronomers can map the unseen dark matter structures that hold the universe together. While this discovery is a major breakthrough, it's only the beginning. Scientists now aim to map more filaments across different regions of the universe to better understand how they shape galaxy formation. Future telescopes, like the Extremely Large Telescope, ELT, will be able to detect even fainter structures, allowing astronomers to explore the cosmic web in greater detail. Additionally, new computational simulations will help refine our understanding of how these filaments evolve over time. Discovery of a 3 million light-year-long filament is a game-changer in our understanding of the cosmos. It confirms long-standing theories, provides new insights into galaxy formation, and offers a new way to study dark matter. More importantly, it reminds us that the universe is not a chaotic scattering of galaxies, but a beautifully interconnected structure, a cosmic web that we are only beginning to understand. So the next time you look up at the night sky, remember, the galaxies you see are not isolated. They are part of a vast hidden highway, stretching across the universe, shaping the cosmos as we know it.